I'm going to do a second video here, more specifically on nomenclature and formula writing. And what does nomenclature mean? Well, it is a term used for giving compounds in chemistry either a chemical name, proper chemical name, or to write out chemical formulas for them. So we're going to tackle ionic bonding in this video. And there are a few different ways that you can name ionic compounds and write their formulas. So we're going to go through the different versions that are here. You have access to this worksheet, so I'm going to run through some of the examples with you, and then you can finish it off on your own. So the first thing that we're going to talk about is binary compounds. Okay, so what binary means in science is two. So it's when we only have two elements in our chemical formula. So if you look at the examples right here that are listed, letters A to V, you can see there you only have two kinds of elements. You might have more than one type of atom. So you might see some subscripts and some numbers, but in all of those examples, you only have, a metal and a non-metal element. So they're pretty easy to name. What we do is we write the name of the metal, okay, full name. And then for the non-metal, we use the suffix IDE. And here are some examples right here. So here's NaCl. Okay, so we go to the periodic table. Na is sodium. We write the full name. Cl is chlorine. But remember, we change the suffix to IDE. So we call it sodium chloride. The next one is magnesium. So we give magnesium the full name. And for bromide, right, so that's the bromine element, we call it bromide. And I know that there's a 2 there after the bromine, but we don't incorporate that, okay? There are times where we would indicate that number 2, but not with ionics, okay? Not with ionics. So I'm going to let you try those. Those are pretty easy. Again, so just state the full name. Even if I just do this one right here with you, state the full name of the metal, and Fr is francium. And then Br is bromine, but you call it bromide. Okay, and you can go through the rest and try those. If you are asked to come up with the chemical formula, they're going to give you the name of the compound. And what you have to do is you have to go and know the charges. So I showed you in a previous video how we can come up with the chemical formula through bonding and showing how the electrons get transferred. But that takes too long, right? That's a lot of work, and we don't need to do that when we have charges on periodic tables ready for us just to go and look at, and then we use those. So you might remember in grade 10 science when we did some nomenclature that we used something called the crisscross rule to switch charges. So if we take a look at magnesium and chlorine or chloride, you can go to the periodic table and you can look up the charge on magnesium and you can look up the charge on chloride. And I'm going to show you where that is on the periodic table that we've been using. So if you click on it, again, you go and you find magnesium, and there in the corner, oops, let me get my pen ready here. There in the corner, you'll see a charge of +2. And for, I think it was chlorine, you'll see a charge of -1. So you come back to your name, and I always say it's a good idea to write those charges just above each of the names of our elements. And then we crisscross them. So we bring the 2 down after chlorine, and we would bring the 1 after magnesium. And this is how we get that formula. But notice that we don't write in the number 1. We tend to leave 1s out. For lithium nitride, same thing. We head over to the periodic table. So we need lithium and we need nitrogen. So here is lithium just above here. On magnesium, charge of +1. Nitrogen has a charge of -3. So we come back and we indicate those charges above each of the names of my elements. And then we do the crisscross rule. So we would bring the 1 down after nitrogen. We would bring the 3 down after lithium. And this is why you see the formula that you do there. Here's another example that I'm just going to do off to the side for you. So if I said to you, come up with the chemical formula for calcium oxide, we would go to the periodic table and we would look up the charges on calcium and on oxygen. So let's do that. So here's calcium right here. He's got a charge of +2. There's oxygen on the other side. He's got a charge of -2. And so we're going to bring those over. We're going to write them above each of our elements. So we're going to crisscross these. We're going to bring the 2's down after each and convert to a chemical formula. So you'll say Ca2O2. But right here it says reduce if necessary. So with ionics, if you can reduce the numbers to lowest terms, you would. And in this case, both of those can reduce, and you would just have a formula of CaO. So again, you can give those a try, write the charges above each of the names, and then you can try to come up with the chemical formulas for them. There are a whole bunch of ions that exist that are called polyatomic ions. And these are important because they are groups of elements that are bonded together in a way that they cannot be changed. So they have a very, very specific formula and a very specific name and a very specific charge. Now, where do you find these? So in your resource note, you have a chart that's there, but I'm also going to have a PDF file right here available to you, and you're going to see all of these polyatomic ions listed. So notice something like nitrate, for example. So the first one that's here. Nitrate has a very specific name, because notice right below it, there's nitrite. And nitrate's formula is NO3, and he has a charge of -1, always. Okay, so a nitrate is NO3 with a -1, but notice that a nitrite is an NO2 with a charge of -1. So different name and a different number of oxygens that are there. And you'll see for some of them, here's like a series with chlorine. Look at all the different numbers of oxygens that exist. The charges are the same though. And then the names all become slightly different. So you really have to pay attention, and you have to make sure that you have the right name and that it matches the proper formula. Now, the nice thing about polyatomic ions, you don't need to do anything to these names. Okay, so what you see as the name of the polyatomic, that's what you write down when you're writing out the chemical formula. So let's do an example or two here with polyatomics. So what you'll have is you'll have a metal and you'll have some non-metals, but they are in this polyatomic ion structure. And you'll know, okay, so here's an example, CaSO4. I'm just going to write it over here. So you'll see calcium, and you should recognize. And then notice now we see an extra 2 elements listed there. So this is different than the page before where it was 2 elements in total. Now I have 3 elements here. And that's sort of a clue that one of them is going to be a polyatomic ion. So we know that Ca is calcium, so we still write the full name of the metal. But the nice thing is you can just go and hunt for SO4, and then whatever its name is, you call it by that name. So if we go back to the chart, we're going to look for SO4 on our chart. There it is right there. Okay. And we call it sulfate. Okay, so we call that name calcium sulfate. Here's another one. Okay, so there's NaHCO3. So see how you have all these elements right away. It's a big clue that you're using a polyatomic ion. So you should recognize the metal. So sodium is the metal. And then the rest of it there, HCO3, you go to your polyatomic ion chart and you start hunting for it. Okay, so let's see if it's around. Here it is right here. Okay, I'm going to change the color so that it's a little bit easier to see. So here it is right here. Okay, and the name of this polyatomic ion is called hydrogen carbonate. And so you write that down. And it was bonded with sodium, and there is your full name, sodium hydrogen carbonate. I'm going to do another example for you off to the side. So I'm going to do, let me do this one. So here I'm going to give you that formula right there. Okay, so you'll see the bracket that is there, and there's a 3 that we bring down after that. And you can see that you have Al is one of your ions, and everyone should recognize that that is aluminum. And we write the full name. And then you should say to yourself, okay, NO3, that's like more than one extra element, so that's got to be a polyatomic ion. And then you come and you hunt for it. And it's got to be there. There it is. Okay, and we call it nitrate. And that's all you do. Okay, so you just write out the name of the polyatomic. So you can give these a try, and again, try to find all of these polyatomics. Hopefully they're listed on all of the charts that you have. There's a lot of them. Sometimes we don't list all of them there, but hopefully you can find them. Okay. Then when we move to the formulas, it's exactly the same as the other ionic formulas. So I would be writing the charges above each of my ions and then doing the crisscross rule to come up with the formula. So I'll do an example or two for you here at the bottom. So I'm going to give you some different names. That way you can practice in the list above. So I'm going to do, why don't I do... let's do calcium chlorate as one example. So we go to our periodic table and we look up the charge on calcium. Okay, so calcium, when you go to the periodic table, you'll see him and he has a charge of +2. Now, chlorate is different than chloride. Okay, when you see this ATE suffix, that's telling you that you have a polyatomic ion. If it was chloride, then it would be the element chlorine. So instead, you're going to come over here and you're going to look for chlorate. There he is right away. And you're going to take that whole formula and the charge. Don't forget about the charge. And you're going to write it down. So the charge is -1. And we're going to now put together this formula. Calcium was a Ca. Chlorate was ClO3. And we're going to bring these charges down. Okay, so a 1 comes after calcium, but this 2 comes down after chlorate. And I have to bracket that because if I don't, I'm going to have a very silly looking formula. I'm going to have something like this, CaClO3. And then if I bring that 2 down, I'm going to have what looks like 32 oxygens. And that is impossible to have in a bonded chemical compound. So make sure that you use brackets, and you can use brackets all the time if you want, if it's easier for you. But just be aware that you need that in that particular case. Here's another example that I'm going to give you. Let me do... silver phosphate. Okay, so again, we go to the periodic table. And let's go to the periodic table. And oh, right away, I see silver right here. Here's silver with a charge of -1. Okay, so we go back and we'll write it down. So there's silver, and he has a charge of +1. We need to know that because of the crisscross rule. And again, if it was phosphide, IDE, I know it's the element on the periodic table. When I see 8 or ite, then I know it's a polyatomic ion. So I go to my polyatomic ion sheet. And again, print these off, folks. It's just so much easier to have them beside you. And here he is. Now, careful, because there's all kinds of versions with phosphate, but we just want this one right here. And phosphate's formula is PO4 with a charge of -3. So here's PO4. And remember, we have to put the charge of -3, and we're going to do crisscross rule. So we're going to bring these charges down. Now, we're bringing a 1 down after phosphate, so I'm not going to see too much, but I'm going to bring the 3 after silver, and there is my compound's formula. So give these a try and see what you can do. Here is the stock system. Okay, and this is now a case where you have certain metal ions that have more than one charge. So we're going to head over to the periodic table again, and we're going to look at some of these. I'm just going to erase a little bit here. So erase some of these, get that out of the way. And let's take a look at some of these metals, particularly in like the transition metals here, where they have more than one charge. And this can get confusing because you have to indicate the charge on these metals, both in the name and of course as you come up with the formula for the crisscross rule. So the stock system addresses this. So this is where your metal has more than one charge. We call the term multivalent. And what we do is we write the name of the metal, and then we write the charge using Roman numerals in parentheses, so in brackets. And then we just write the nonmetal or the polyatomic ion as usual. If we need to come up with the formula, the name of it and figure out the charge, then we have to actually reverse that crisscross rule in order to determine the charge on the metal, because sometimes it's been reduced, and so we will have a difficult time figuring out the exact charge. So here are a couple of examples that we'll do together. So here's iron 3 oxide. Okay, so when you see that 3 in brackets, that is telling me the charge on iron. Okay, it's telling me that iron's charge is +3. When I see oxide, that IDE is typical of just the element alone. So this is oxygen. What's the charge on an oxygen? Well, you go over to your periodic table. Here's oxygen over here. Here's his charge of -2. We write the -2 down, and then we do the crisscross rule. Okay, so iron's formula is Fe. I bring the 2 down from the oxygen. I write the O, and I bring the 3 down from the iron for the crisscross rule. For cobalt 2 sulfide, okay, so they're telling me the charge on cobalt. I don't even need to go look it up. So cobalt's charge is +2. And then for sulfide, I will go and we'll look up the charge on sulfur. So sulfur is right below oxygen, so they have the same chemical charge. And I'll write that there. And then we're going to do the crisscross rule. And notice that it's the same charge. So you can reduce charges in ionic compounds. Okay, so you're actually just going to have COS because both of those 2's will cancel out. Now let's come up with the names for these 2 right here. And for the first one, I have Cu2O. And you cannot just say, okay, this is copper and oxygen, so this name is copper oxide. You cannot do that. Okay, no. Because when you go to the periodic table, you notice that copper has 2 charges, and you have to tell me what version of copper is in the formula that we're looking at. So the way we do this is we reverse the crisscross rule. So if I am taking a look at this formula, we don't write it in, but we know that there's a 1 there after the oxygen. So we kind of reverse that and we say, okay, copper should have a charge of +1, and then oxygen should have a charge, not +2, but -2. And then what you need to do is just double check that, because sometimes we reduce ionic compounds and their formulas. So you want to make sure that copper has a charge of +1 and that oxygen has a charge of -2. And he does. Oxygen is -2, and it's possible that copper could have a charge of +1. And you have to check that because, again, maybe they reduced the subscripts. So let's clean this up and get rid of all of that and write this down. So this now is telling me, that copper has a charge of 1, which we put in brackets, and is bonded with oxide. Now, look at the next one here. So CuO. If I reverse the crisscross rule, according to that formula, and I'm just going to write it over here so it's a little bit bigger. So we don't write them in, but we know that there's 1s there. Okay, so we don't write them in. We never show the 1s, but if I was to reverse the crisscross rule, that is telling me that copper has a charge of 1 and oxygen has a charge of 1. And here's a great example of why you have to go and check the charges on both elements, because sometimes it works out for one but not the other, and then we know that it's been reduced. So we're going to head over to the periodic table, and again, we take a look here. Let me just clean this up. And copper can have a charge of +1, but oxygen cannot have a charge of -1. And that's what we're showing in the other example. Oxygen has to be -2, which means copper also has to be +2 because we've reduced the charges, okay? So we know that oxygen has to be -2, and in order to get that, we multiply it by 2. You also have to multiply the charge by 2 on copper. So copper becomes copper 2 oxide in this case. And I'll tell you folks, this is the toughest part right here. Okay, so coming up with the names of metals that have more than one charge, it is a bit tricky to do that. Okay, so try these, give these a go. This is going to be easier. Okay, number 6 here will be easier for you to do because you can just look up the charges and do the crisscross rule and reduce if you need to. These ones here are going to be a little bit more tricky for you out of the whole page. Okay, and then we'll stop there for today. That will take us to the end of Ionic nomenclature. That's a lot, right? We have a lot to cover right here. But we can do it. We did a lot of this in grade 10, and maybe we're adding on a little bit here with the stock system, maybe with the polyatomics. And your resource note also has all kinds of great examples there that you can reference as well.